Let us discuss redox reactions. In the redox reactions, first we will see oxidation numbers we will see. Then we will go for redox reactions. What is oxidation number? Oxidation number means charge of an atom in the given species. One atom is having what charge, that is called oxidation number of that atom in the given species. Suppose we are taking the compound called potassium permanganate we are taking. In the potassium permanganate, let us take the manganese we will take. Manganese we are taking. This manganese is having what charge in the potassium permanganate? That charge is called oxidation number of manganese in potassium permanganate. Sorry. What is the rule to find oxidation numbers? For finding oxidation numbers, certain rules are there. Those rules we will take. Now we will take element. We will take element. We are taking. In the element, atom is present. That is having oxidation number. How much means 0. So any element you take, in the given element, the constituent atom charge is how much means 0. That means oxidation number is 0. Suppose we are taking phosphorus element. Phosphorus is formula P4. In P4, the phosphorus atom oxidation number is 0. Sulfurs we are taking rhombic sulfur. Rhombic sulfur we are taking. In the rhombic sulfur, the sulfur atom oxidation number is 0. Next, we will take a ion. We will take ion. Suppose we are taking a sodium ion. Now charge of sodium is +1. That is the oxidation number of sodium ion. We are taking Cl minus. For Cl in this one is having charge -1. Therefore, Cl oxidation number here is -1. We are taking sulfide. This sulfur oxidation number is -2. Its charge is its oxidation number. Suppose we are taking phosphate. Now, two different elements are there. Therefore, 3 minus is the oxidation number of phosphate. Like that, we should not say. Okay, sir. So we should not say in this way. Suppose we are taking Al3 plus aluminum. It is aluminum ion. Here aluminum charge is 3 plus, we can say. S2 2 minus is there. Here 2 sulfur atoms are there. Therefore, -2 is the oxidation number of sulfur. We should not say. Okay, only one atom should be there. Then it is, if it is having charge in the sense, then that charge is called that oxidation number, we can say. So, for ion, we said like this. Then we will take a fluorine in the compound. Fluorine is present in the compound. Fluorine is present in the compound means that oxidation number you have to say -1. Fluorine present in the compound. Then its oxidation number you have to say -1. For example, HF. Here fluorine oxidation number we have to say -1. Then H2SiF6. Here fluorine oxidation number we have to say -1. C2F6. Here fluorine oxidation number we have to say -1. So fluorine oxidation number we have to say -1 in its compound. In the elemental form, we have to say 0 oxidation number we have to say. Elemental form in the sense F2. Now F2 is called a molecule or element, we will say. In this element, fluorine oxidation number is 0, we have to say. In the compounds, we can say fluorine oxidation number -1, we can say. Sir. Now, NF3 will take. Here, fluorine oxidation number -1. OF2 will take. Here, fluorine oxidation number -1. O2F2 will take. Here, fluorine oxidation number is -1. So, if fluorine is present in the compound, then you say that oxidation number is -1, you say. Okay. Then If chloride is given, chloride, then you say Cl is having -1 oxidation number. Bromide, bromide is there, then you say bromine oxidation number -1. Iodide, then you say iodine oxidation number is -1. Iodide means iodine oxidation number is -1. Bromide means bromine oxidation number is -1. Chloride means Cl oxidation number is -1. Like that we have to say. Sulfide, sulfide means sulfur oxidation number is -2 we have to say. So, next, oxygen is present in the compound. Oxygen is present in the compound. Then that is generally oxides we will say. Oxygen present in the compound means that we will say generally oxides. Oxide means oxygen oxidation number is -2 we have to say. Oxygen oxidation number is -2 we have to say. So, oxygen in its compounds means oxygen oxidation number is -2, but except OF2, O2F2. Here for fluorine only -1, oxygen not minus. For fluorine negative oxidation number, for oxygen not negative oxidation number. Here also fluorine negative oxidation number, for oxygen negative oxidation number not there here. So it is exception. So generally oxygen present in the compound means for that oxygen we will give -2 we will give. Exception is what? OF2, O2F2. Here for fluorine only -1. For oxygen negative oxidation number not there for these two. In these two, oxygen is not taking negative oxidation number. Fluorine only taking -1 oxidation number. Sorry. Here in the oxygen, in some compounds, oxygen present in the form of peroxide. In some compounds, oxygen present in the form of peroxide. For peroxide, what is the formula? Means O2 2 minus. For peroxide, formula is O2 2 minus. One peroxide ion, formula O2 2 minus. One peroxide ion means O2 2 minus. Like that we have to say. One peroxide ion means O2 2 minus. 2 times peroxide ions means 2 times O2 2 minus. Like that. How peroxide will be there? Peroxide means O, 2 oxygens will be there in one peroxide ion. That 2 oxygens we have written. Then you give this -2 for both oxygens equally, -1 for this oxygen, -1 for this oxygen. Then oxygen valence shell contains 6 electrons because 6th A group due to -1 additional 1 electron. So 7 electrons will give for this oxygen. In the same way, 7 oxygens for this oxygen. Okay. So for both O minus, we have given 7 oxygens. Then you give bond between these two electrons. Give bond. It is called peroxide. O single bond O for this oxygen -1, for this oxygen -1. O single bond O for this oxygen -1 we have to give. For this oxygen -1 we have to give. This is called what in the sense? Peroxide. Peroxide ion means like this. In the peroxide, each oxygen is having how much oxidation number? -1. For this oxygen charge is -1, so its oxidation number is -1. For this oxygen charge is -1, so this oxidation number is -1. Okay. So peroxide means oxygen oxidation number we have to say how much? -1 we have to say. Okay. So peroxide means oxygen oxidation number we have to say -1. Then this oxygen present in the form of superoxide. Superoxide. Superoxide formula is O2 minus. One superoxide ion. One superoxide ion means formula O2 minus. What is the structure of this? 2 oxygens. That 2 oxygens we have written. -1 we will distribute equally. Here -1/2. Here -1/2. This oxygen comes under 6th group. So this valence shell contains 6 electrons. 6 electrons. This oxygen also comes under 6th group. So this valence shell contains 6 electrons. minus of minus 1. Minus 1 means additional 1 electron. Minus 1 means additional 1 electron at center, for common for both. Then we will give the bond. We will give the bond here like this. We have given the bond like this. It is superoxide ion. In this superoxide ion, this oxygen is carrying minus 1 by 2 oxidation number. In this superoxide ion, this oxygen is carrying minus 1 by 2 charge. This oxygen also carries minus 1 by 2 charge. So this oxidation number is how much? Means minus 1 by 2. This oxidation number is minus 1 by 2. This oxidation number is minus 1 by 2. Like that we can say. Sir. So oxygen means generally we have to give minus 2 oxidation number in its compound. Peroxide means minus 1. Superoxide means minus 1 by 2. But in these two compounds, oxygen is taking positive oxidation number in these two compounds. Sir. In which cases and all peroxide is possible? One is sodium peroxide, NaO2. Potassium peroxide, rubidium peroxide, cesium peroxide, barium peroxide, barium superoxide. Superoxide possible like this: sodium superoxide, potassium superoxide, rubidium superoxide, cesium superoxide, barium superoxide. Here oxygen oxidation number is minus 1 by 2. That means oxidation number can be fraction. Then alkali metals, that is lithium, sodium, potassium, rubidium, cesium, francium, in their compounds always shows plus 1. Alkali metals in the compounds always shows plus 1. Then alkaline earth metals, beryllium, magnesium, calcium, strontium, barium, radium, in their compounds they show plus 2 oxidation number. So suppose we are taking calcium carbonate. In the calcium carbonate, calcium oxidation number is plus 2. Alkaline earth metals can show plus 2 oxidation number in their compounds. Then hydrogen in its compounds show plus 1. For example, HCl, hydrogen shows plus 1. For example, H2SO4, hydrogen oxidation number is plus 1. 2 hydrogens are there. For 1 hydrogen, plus 1. 2 hydrogens means plus 2. H3PO4, here hydrogen is plus 1. So CH4, hydrogen is plus 1. So hydrogen in its compounds exhibit plus 1 oxidation number. Here exception is there. What is the exception? Alkali metal hydrides will take. Alkali metal hydrides. Alkali metal hydrides LiH, NaH, KH, RBH, CSH. Here hydrogen oxidation number is minus 1. In the alkali metal hydrides, hydrogen oxidation number is minus 1 in these compounds. Alkaline earth metal hydrides, CaH2, SrH2, BaH2. Here hydrogen oxidation number is minus 1. Hydrogen oxidation number means for 1 hydrogen atom minus 1 oxidation number we can say. For 1 hydrogen atom minus 1. 2 hydrogens means totally minus 2. Aluminum hydride. Here hydrogen oxidation number is minus 1. Sir. Next. Now, if the species, total charge of the species, total charge of the compound always 0. Total charge of the ion always equal to its net charge. Suppose total charge of a compound is 0. For that we will take one example. Suppose potassium dichromate. Total charge is 0. Net charge is 0 for this. We will take here sulfate. Here net charge is how much? Means 2 minus. Here we will take SiF6 2 minus. Here net charge is 2 minus. Now I will take FeCN 6 times 4 minus. Net charge is 4 minus for this. Total charge is 4 minus for this. We will take like this. CO NH3 6 times 3 plus. For this total charge is plus 3. For this total charge is plus 3. For this total charge is minus 4. For this total charge is 0. Now I will take like this. For this total charge is 0. Okay. Now we will take, we have given some rules for this. Some rules we have given. Using these rules, how to find oxidation number of unknown species, unknown atom in the given compound. That we'll see. Oxidation number of given compound, given unknown species in the compound, that we'll see. Now we'll take sulfuric acid. In the sulfuric acid, how to find sulfur oxidation number, that we'll see. Here, in this sulfuric acid, 2 hydrogen atoms present, 1 sulfur atom present, 4 times oxygen is present. Total charge how much means 0? Because it is not ion. It is not ion. Therefore, total charge is 0 for this. Total charge we can say 0. Sir. Now, how to find sulfur oxidation number, that we'll see. For which rest of the oxidation numbers you substitute. Now hydrogen. Hydrogen oxidation number is how much? Hydrogen in its compound will exhibit how much oxidation number? +1. When -1? In these cases. In these cases -1. Otherwise +1. Sulfur oxidation number we have to find. 4 times oxygen. Oxygen in its compound in the sense -2. If peroxide or superoxide is there, then only different. Otherwise -2. Oxygen oxidation number -2. Net charge, total charge equal to how much? 0. So find sulfur oxidation number, how much means +6. So we got sulfur oxidation number, that is +6 we got. Now we will take H3PO4. In this H3PO4, we will find phosphorus oxidation number. In this one, 3 hydrogen atoms present, 1 phosphorus present, 4 oxygen atoms present. Net charge 0. For hydrogen we can write +1. Phosphorus we have to find. Oxygen we have to write -2 equal to 0. So phosphorus oxidation number how much means +5. In this way we can find oxidation numbers. Sir, we will take K2Cr2O7, potassium dichromate. Here we will find chromium oxidation number. Here potassium present 2 times, chromium present 2 times, oxygen present 7 times. Total charge 0. Total charge is 0. Net charge is 0. Now potassium oxidation number we will substitute +1. Chromium we have to find. Oxygen oxidation number -2 equal to 0. So chromium oxidation number we are getting +6. Next, given is permanganate MnO4-. Which oxidation number we have to find in the sense manganese? So manganese present 1 time. Oxygen present 4 times. Total charge is -1. Net charge is -1. Net charge -1 for this. Now, manganese we have to find it. Oxygen oxidation number substitute -2 equal to net charge -1. From this, we can find manganese oxidation number +7. we can find manganese oxidation number plus 7. So we found manganese oxidation number here. Like this only we have to find oxidation numbers we have to find. Sir, now we will take LiAlH4, lithium aluminum hydride. Here aluminum oxidation number we will find. Aluminum oxidation number we will find it. Okay. Now, in this compound, is there any alkali metal or alkaline earth metal is there or not? You see. Yes, it is present. Alkali metal is there means for that you give +1. So alkali metal +1 you are given, rest of the part is AlH4 -1. Alkali metal is there means we can split and write. Alkaline earth metal is there means we can split and write. Sir, we have written like this. Now, which oxidation number we have to find? Aluminum. So aluminum oxidation number we have to find. Hydrogen 4 times present. Net charge is equal to -1. Now, aluminum oxidation number we are finding. Hydrogen oxidation number we are substituting. Hydrogen oxidation number how much means? If hydrogen is present along with alkali metals, then it is called alkali metal hydrides. Alkali metal hydrides means alkali metal will be present, hydrogen will be present. Then hydrogen oxidation number you have to give -1. Alkaline earth metal hydrides means alkaline earth metal present and hydrogen is present. Only these two elements will be present. Hydrogen oxidation number we have to give -1. Aluminum hydride, aluminum with hydrogen means give hydrogen -1. So here aluminum is combined with hydrogen. So give -1 for this hydrogen. Then net charge how much means -1. So find aluminum. Aluminum you are getting +3. Aluminum oxidation number we got +3 we got. So now next compound we will take. We will take a what compound in the sense C2H5OH. We have taken C2H5OH we have taken. Carbon oxidation number let us find. Sorry. We are saying that carbon oxidation number we have to find. We are saying why we are not saying oxygen or hydrogen. In the same way in previous cases if you see oxygen, hydrogen we are not saying, alkali metal we are not saying, some other thing also, some other thing only we are saying, because most of the elements show variable oxidation numbers. For example, manganese if you take, it will show +2, +4, +6, +7. Due to variable oxidation numbers only, we are finding that element oxidation number. In the rules we have given, alkali metal means +1, because alkali metals always shows +1. It cannot show other than that. Element means 0. In the compound means alkali metal will show only +1. That's why we said in the rule, alkali metal means give +1. Similarly, fluorine means give -1, because fluorine is highest electronegative element. Therefore, for that it will show -1 only, except in one case, HOF case. Okay. Therefore, general things we have given. Now, underlying things are showing variable oxidation numbers, so that we are finding that oxidation number. Even carbon also shows variable oxidation numbers. It will show +2, it will show +4, -1, -4. Like this, it will show carbon. Therefore, only carbon is showing variable oxidation number, so that we are finding carbon oxidation number. Okay. So carbon 2 times present. Hydrogen totally 6 times present. Oxygen 1 time present. Total charge how much means 0. Okay, sir. Carbon we have to find. Hydrogen we are substituting +1. Oxygen we are substituting -2, equal to 0. Therefore, we are getting carbon how much in the sense +2 we are getting. Carbon oxidation number we are getting as how much? +2 we are getting. Okay. Next, we will take Cr2O3. Cr2O7 2-, CrO4 2-, Cr2SO4 thrice, CrO5. In this, we have to find chromium oxidation numbers. In all cases, find chromium oxidation number. Chromium oxidation number you have to find. Now, in this Cr2O3, chromium oxidation number we have to find it. How to find? Criss-cross method, cross multiply. So chromium is +3, oxygen is -2. Okay. So chromium oxidation number +3. Otherwise, in a regular manner also you can find it. So chromium is 2 times, oxygen is 3 times, total charge 0. Chromium we have to find, oxygen we are substituting, oxygen is -2 equal 0. So chromium is +3. Like this also you can find it. Sir. Next, in dichromate, chromium oxidation number we have to find. So 2 times chromium, 7 times oxygen, net charge equal to -2. So chromium, oxygen -2 we have to substitute, net charge -2. So chromium is how much? Means +6. Chromate. In chromate, chromium oxidation number you have to find. Chromium, oxygen 4 times, net charge equal to -2. Chromium, oxygen oxidation number -2 equal to -2. Chromium is how much in the sense? +6. Chromium oxidation number how much? Means +6. In this case, what we have to do? Here, cross multiply. Cross multiply it like this. So chromium +3, sulfate -2. Okay, so chromium oxidation number how much? +3. Otherwise, normal way also you can find. So 2 times chromium, 3 times sulfur, 12 times oxygen, total charge 0. Chromium we have to find, sulfur we have to substitute. How much we can substitute? Sulfur shows variable oxidation number, -2, +2, +4, +6. Like this sulfur is showing. Then how to find? We cannot find. But if we know about this, we can find. It is sulfate. In sulfate, it is sulfate ion. In sulfate ion, what is the oxidation number of sulfur? Sulfur, that we will see. Sulfate. Sulfur we have to find. 4 times oxygen equal to -2. So sulfur, oxygen is -2 equal to -2. So sulfur is +6. So sulfur is +6. Oxygen is -2 equal to 0. Therefore, chromium is +3. Chromium we will get +3. Like this we can find. Okay. Next, CrO5. In CrO5, what is the oxidation number of chromium? That we will see. Now we are taking a CrO5. Cr oxidation number we have to find. Cr 5 times oxygen equal to 0. Net charge 0. Chromium plus oxygen is -2 equal to 0. So chromium is equal to +10. Chromium oxidation number is equal to +10. Sir, we are finding oxidation numbers. The found oxidation number is correct or wrong? How to find it? How to see? We have got chromium oxidation number is +10 in CrO5. Whether it is correct or wrong, how to find? That we will see. Now we will take chromium. Its atomic number is 24. Its electronic configuration is argon 3d5 4s1. It is anomalous electronic configuration. It is violating which rule? In the sense of Abba principle. Set. So chromium electronic configuration we have written like this. In this chromium electronic configuration, this argon part is not involving in chemical reaction. In this 18 electrons are there. These 18 electrons do not involve in chemical reaction in the chromium. That's why we have written that 18 electrons as argon. How argon is not participating in chemical reaction? Like that, here also these 18 electrons do not involve in chemical reaction. That's why that 18 electrons we have written as argon. 3d5 is involving in chemical reaction. 4s1 is involving in chemical reaction. Therefore, 3d5 4s1 is called a valency shell. So from the valency shell, electrons involve in chemical reaction. Now, if chromium is contributing 1 electron, then it will show +1 oxidation number. If it is donating 3 electrons, it will show +3 oxidation number. If it is contributing 6 electrons in a chemical reaction, then it can show +6. So chromium can show oxidation number like this. Okay, sir. In the chromium, the valence shell contains 6 electrons. Therefore, chromium comes under 6b group as per European system. Sixth group, chromium comes under sixth group. This valence shell contains 6 electrons. Okay, now we will see CrO5. In CrO5, we have calculated chromium oxidation number as plus 10. That means chromium is donating 10 electrons in a chemical reaction, then only plus 10, isn't it? So chromium is donating 10 electrons in a chemical reaction, that's why it is showing plus 10 as per this. Now whether it is correct or wrong, we'll see. Can chromium donate 10 electrons and show plus 10? Can chromium donate 10 electrons? Cannot. Why chromium cannot donate 10 electrons? Because its valence shell does not contain 10 electrons. This argon part, this is having 18 electrons. This part is not involving in chemical reaction as per experimental results. So this part is not involving in chemical reaction. Only this part is involving in chemical reaction. So chromium can donate maximum 6 electrons. Therefore, chromium can show maximum plus 6 oxidation number because this group number is 6b. Its group number is 6b. It indicates that it can show maximum plus 6 oxidation number. So in CrO5, chromium can show plus 6 but not plus 10. Chromium can show maximum plus 6 but not plus 10. That means all the oxygens are not oxides. Some may be peroxides. Okay. So here chromium oxidation number we have calculated as plus 10. That is impossible. Chromium can show maximum plus 6 only because its valence shell contains 6 electrons. So chromium oxidation number maximum plus 6. That means here all the oxygens are not oxides. Some are peroxides. That's what we got idea. Set. Now we will take chromium. Some oxygens is carrying -1 oxidation number in the peroxide. In the peroxide, oxygen carrying -1 oxidation number, and some are oxides. Oxides means -2. Net charge equal to 0. See that chromium can show maximum plus 6 only. It cannot show plus 10. This indicates all the oxygens are not oxides. All the oxygens cannot carry -2 oxidation number. That means some of the oxygens can carry -1. Some of the oxygens can be as peroxides. Why not superoxides? Superoxides means alkali metals and alkaline earth metals. So here some of the oxygens carrying -1 oxidation number. How many oxygens carrying -1 oxidation number? Suppose X. X number of oxygen atoms carrying -1 oxidation number. Remaining oxygens, that is pi minus X, carrying -2 oxidation number. Now we will find X. So we are getting X. X is equal to how much in the sense 4 we will get. That means 4 oxygens carrying -1. Remaining 1 oxygen carrying -2. Therefore, in CrO5, 5 oxygen atoms are there. 5 oxygen atoms are there. How these are taking charge? 4 oxygen atoms are taking -1. 1 oxygen is taking -2. Okay. So -1 oxidation number means that is called peroxide. One peroxide ion means that formula is O2 2-. Here 4 oxygens carrying -1 means what? 2 peroxide ions are present. So we'll see the structure. Chromium. It is containing 2 peroxide ions, we said. Okay. Peroxide ion structure we have drawn already. Peroxide ion structure we have drawn. O single bond O, each oxygen carrying -1 oxidation number we have said. So here 2 peroxides are there. 2 peroxides. We have written like this. This oxygen is making bond with chromium. This is also making bond with chromium. Like that here also. Here O single bond O. This is called peroxy linkage, peroxide. This O single bond O. This linkage is called peroxy linkage. This is called peroxide. This oxygen carrying -2 oxidation number, that makes a double bond with the chromium. This is CrO5 structure. It is looking like butterfly, therefore it is called butterfly structure. It is called this name is called what, in the sense chromium peroxide. Chromium peroxide, like that we have to say. This name is chromium peroxide, we have to say. So in the chromium peroxide, chromium oxidation number is what, means +6 but not +10. If oxidation number comes more than its group number, then you conclude that in that compound, some of the oxygens are peroxides, some of the oxygens are oxides. Then how many peroxide, how many oxide? In order to calculate that, give the maximum oxidation number to that metal. Maximum oxidation number means it's a group number. It's a IUPAC group. That means a European group number. But in copper family, coinage metals, copper, silver, gold, rhodium, for those elements, the European group number is 1b, but copper can show +2. That is exception. Okay, so next we will take H2S2O8. In this one, we will find a sulfur oxidation number. Sulfur oxidation number, we will find it. Okay, so 2 times hydrogen, 2 times sulfur, 8 times oxygen. Total charge is equal to 0. So hydrogen oxidation number +1, sulfur we have to find it. Oxygen oxidation number -2 equal to 0. So we are finding sulfur oxidation number, how much it comes, means +7. On simplifying this, we are getting +1. Whether it is correct or wrong, we will check. Sulfur electronic configuration we will write. Its electronic configuration is neon 3s2 3p4, because its atomic number is 16. Here 10 electrons present. These 10 electrons do not involve in chemical reaction from sulfur. Only these 6 electrons involve in chemical reaction. Okay, only these 6 electrons involve in chemical reaction. Therefore, we can call this as valence shell. Valence shell contains 6 electrons. Therefore, sulfur can contribute or can donate maximum 6 electrons in a chemical reaction. So sulfur can show maximum +6 oxidation number. It cannot show more than +6. So sulfur maximum oxidation number is +6, but we got +7. This indicates that all the oxygens are not oxides. Some of the oxygens are what? Some of the oxygens are peroxides and some are oxides. So how many oxygens are peroxides? How to know it? How many oxygens are peroxides? How to know it? For that case, what we have to do means make sulfur oxidation number as +6. Then we will find how many oxygens are peroxides we can find. In this sulfur, make this oxidation number as its maximum, that is +6. Its group number is what, in the sense 6a. Group number is 6a. So group number is 6. Therefore, its maximum oxidation number is +6. Take sulfur oxidation number as its maximum, that is 6a. Then find sulfur. Then find oxygen. How many peroxides? How many superoxides? Okay. So 2 hydrogens will write. 2 sulfur will write. X times oxygen is carrying -1. 8 minus X times oxygen carrying -2 equal to 0. Total charge 0. So hydrogen will give +1. Sulfur will give +6. Then this -1 for oxygen. How many oxygens carrying -1? X times. This oxygen, this -1 oxygen means peroxide. Then -2 oxygen means oxide. It is how many oxygens? 8 minus x equal to 0. So we can find x. We can find x is equal to how much means 2. That means out of 8 oxygens, 2 oxygens carrying -1 oxidation number. Remaining 6 oxygens carry -2 oxidation number. So 2 oxygens carrying -1 means here one peroxy linkage is present. In this compound, one peroxy linkage is present. One peroxide ion is present. One peroxide is present. That means O2 2 minus is present. One peroxide is present. Remaining oxygens are carrying -2 oxidation number. So what is the structure of this H2S2O8? We'll see. Now 2 sulfur atoms we will write. Commonly this peroxide will write. Commonly we'll write peroxide. We are writing a peroxide commonly. Okay. Here 2 sulfur atoms we will write. That peroxide we will give common for both. Here peroxy linkage we have given. Peroxy linkage in the sense between oxygen atoms single bond we have to write. Here single bond, here single bond. Between oxygen atoms single bond is there means peroxy linkage. Oxygen will make totally 2 bonds, 1 bond here, 1 bond here. Remaining 6 oxygens, give 3 oxygens to each sulfur. Give 3 oxygens to each sulfur. Then 2 hydrogens are there. That 2 hydrogens give one side, this side 1, this side 1. Left side 1, right side 1. Oxygen will make 2 bonds, here 1 bond, another 1 bond. Here oxygen making double bond, here double bond, here double bond, double bond. This oxygen is having 1 bond, another bond, you give it. Now if we see here, which one is the peroxy linkage? Which one is the peroxy linkage means this is the peroxy linkage. In this one, oxygen is carrying -1 and -1. Okay. This acid name is what in the sense? Marshall's acid. This acid name is Marshall's acid. So now we got Marshall's acid, one peroxy linkage. That point we got it. So next example we will take. H2SO5 will take. H2SO5. In H2SO5, is there any peroxy linkage? That we will find it. Okay, so we will find in a normal way, we will find hydrogen is 2 times +1, sulfur let us find, oxygen is 5 times, that is -2 equal to 0. So let us find a sulfur oxidation number we are getting as how much in the sense +8. But sulfur can show maximum +6 only, no? Therefore, this indicates that out of 5 oxygens, some are peroxides, some are oxides. Okay, to find how many are peroxides and how many are oxides for which take sulfur oxidation number as its maximum value, that is +6. So now hydrogen is +1, sulfur is +6. Some of the oxygens carry -1, some of the oxygens carry -2 equal to 0. So x is equal to 2. That means one peroxy linkage. That means one peroxide ion is present. So sulfur will write here one peroxide ion is present, we can say. Okay, so we have written sulfur here. Out of 5 oxygens, 2 oxygens carrying -1 oxidation number. Okay, so 2 oxygens we have written, O single bond O we have written. For this we have to give -1 -1. Remaining 3 oxygens we will write 1 2 3. Remaining 3 oxygens we have written. Okay, now these 2 hydrogens are there. One hydrogen you give to peroxy linkage, another hydrogen you give to this oxygen. Then we will give the bond. The oxygen will make 2 bonds, 1 bond here, another bond here. This oxygen making 2 bonds, 1 bond here, another bond here. This oxygen making double bond, this oxygen making double bond. Oxygen in the sense that will make double bond. Okay, so like this we are giving structure for this. Here peroxy linkage is present, we are saying. Okay, set.